Well, we are now on the final home stretch. This is the penultimate episode, the penultimate lesson. It is week 6, day 4, the beginning of our capstone project. Although really we've been doing the capstone project all week, but this is the conclusion of the project, a project which is going to bring together OpenAI Agents SDK and MCP into a commercial project that I'm calling Autonomous Alpha Agents, because this is a project applied to financial markets, as you have no doubt guessed. And the idea is that in this project, we're going to doing something that is commercial. It is first and foremost going to be something that we can apply in business. Most of our projects so far have been somewhat generic in that they've been things like a sidekick and something that builds code. And I wanted to do something which could apply to a business vertical and use some kind of a setup that you could imagine applying to many other business verticals. And so we're applying it to financial markets, and we'll be trying to build something that is exciting from a commercial business point of view, as well as from a technical agent's point of view. There's going to be 5 different MCP servers that we'll be using with tools and resources from them. There's going to be interactions between agents, of course. It's going to be fully autonomous. You wouldn't have it any other way. And I need to tell you, do not, under any condition, under any circumstances, use this for your own trading decisions. This is educational and for learning and applying agents to understanding how to use them for business, but not actually to use them for trading decisions. And now for our capstone project, we go to the week 6 folder. We go to lab number 4. And welcome to the lab, introducing you to our project, Autonomous Alpha Agents, our equity simulator. And let me tell you all about what we're going to do. We're going to build an equity trading simulation with 3 traders and a researcher agent, powered by an army of MCP servers with tools and resources. There's 5 of them. The homemade accounts MCP server that we built based on the work of our own engineering team of agents from week 3. Fetch, we're using to get web pages via a headless browser that will be running locally. Memory we'll use in case our agents, our traders wish to save their thoughts. They'll be able to share them too. So this will allow our trading floor to have a kind of shared memory state as they learn about markets. Search via the Brave API, and then financial data, either the free version or the paid version if you wish to entertain yourself as I have done. It's great fun. I say it's worth $20, but I realize that everyone's appetite for this will be different. So look, the goal of today's part of the capstone project is to build a Python module, and that Python module will be called traders.py and will contain a trader class, which will be an independent autonomous agent. But the way I like to do this is I like to start in a lab, in a notebook, because you can iterate over things and explore and work on it there. And then over time, we will migrate to a Python module when we're ready to do so. That is that's how I like to work. And so we'll start in the lab and then move to the module in a bit. But of course, I have to mention one more time, yet again, this warning that you should not use this for actual trading decisions, just in case I haven't said that enough. You're fed up of me saying it. All right, so there's a bunch of imports to get us started, as you'd expect nothing less, and a load.env. And now the first stage is to gather all of the parameters for our MCP servers. So we've defined each of our MCP servers as we've gone with one of these dictionaries that store the parameters for how you launch that server. And now we're going to gather them all together. So we're starting with a group called the trader server parameters, which is going to have our account server where we look up account details, and then the server memory where it can maintain its memory. And we put that into, we also want to have a trader tools that we're going to have as an empty list to start with. And then here we've got a choice. It depends on whether you are using the paid financial services approach. If so, then we're going to add another MCP server, which is the paid financial services with the directory set to this directory here that you should overwrite with the directory that you're using if you're using the paid financial services API. If you're using the free one, then we need to get the tools from the MCP server using OpenAI. Converting it to OpenAI tools using the client that I wrote. And I might replace that. You may see the code here might be tidied up if I am able to get it to work just using the OpenAI MCP client. Okay, so with that, we will collect together these MCP servers, and we will collect them together here, the parameters, and we will collect a couple more for the researcher. We're going to collect fetch, and we're going to collect the Brave search. So fetch, you'll remember, that's the one that is going to sort of spawn a headless browser on our computer that we won't see, but it's going to happen behind the scenes using Playwright. And it will use that to search the web and bring in web pages and retrieve their contents. But the more powerful one is Brave. Brave is where it will call out to the Brave search engine, which will run a search and bring back information relevant to that search. So these are the two tools, just a web query and a web search, a fetch and a search. So let's bring them in as well. And now we have gathered all of our parameters. Okay, next up, we want to actually create the MCP Server Studio, the standard input output for each one of our params. So what we're going to do is we're going to have a list of let's start with the researcher. So we're going to have a researcher. I hate it when Cursor fills it all in for me. That's going to take away the fun. The researcher MCP servers, the MCP servers for the researcher is going to be, and it's got it wrong, which is nice, MCP server standard input output that we're going to want to create given the params, and it's got it all right now. It's given the parameters, and we're going to set the cache tools list to true. We do want to cache them, so it doesn't have to create them every time for the parameters in this set here. And then we just want to repeat this basically a second time, but this time we want it to be for the trader parameters. For those, we're going to want to come up with trader MCP server. So now we're creating a trader MCP server for every set of parameters in the trader MCP server parameters. You see what I mean? We're just iterating through these sets of parameters and creating the servers. All right. And then we will just say MCP servers is those two added together. Those two lists together make all of our servers. So now we have created our MCP server stdio for all of these. Okay. And I will run the creating of the new servers, and let's get on with it. So we're going to be creating two agents in this lab. One of them is called the researcher, and one of them is called the trader. And the researcher, of course, does market research on the behest of the trader, and the trader makes trading decisions. And we're going to arm the researcher with tools to look online, and both in the headless browser and by doing an actual search using Brave. And now you might wonder, why not just simply give those two tools to the trader? Just give all the tools to the trader and let the trader do everything autonomously and just have control over all of the different tools it uses. And you certainly can do that, and it might be worth experimenting with. A benefit of separating out the researcher is that it allows you to focus your prompting on one task to make sure that you don't distract the trader agent too much with too much optionality almost, so that there's some goals, some tighter objective around research that we can set the researcher agent. And we also give it both of these tools. And if we were to give all of these tools to the trader agent, there's a risk that we confuse it by just giving it too many different tools that it could use. So this technique of trying to identify different steps, different stages, and then identifying an agent around it, it's a great way to tackle agentic projects. And it's experimental. There's no hard and fast rules. Sometimes it helps to give more flexibility to one agent with just a greater number of tools. Sometimes it helps to put boundaries around an activity and carve off an agent for that activity. And that's what we're doing right now. So the researcher agent, we're saying the instructions for, we're writing a coroutine get researcher, instructions, which is the system prompt. You are a financial researcher. You're able to search the web for interesting news, look for possible trading opportunities, and help with research. Based on a request, you carry out necessary research, responding with your findings. And then we end by saying the current date time is, and give the current date and time. It's just, again, a good tactic to arm the research agent with that information so that it doesn't think it's still its knowledge cutoff date, which might be October of 2023 or something. So we're giving it the current date, and that could be provided as a tool, but again, that would be a sort of needless distraction to confuse it by making it have to also call an extra tool. We might as well just shove that in the context every single time. And so with that, this will create an agent object, an OpenAI agents SDK agent. The name is researcher. The instructions is this system prompt. We'll use GPT-4o mini for now, and we are passing in our MCP servers that get brought in here. So we will pass them in to be the MCP servers for the researcher, and that I will run. And now I'm going to do this, a get researcher tool, which is going to return the researcher converted into a tool using the as tool function that the OpenAI Agents SDK gives us. Do you remember this? You remember that when you've got agents collaborating with the Agents SDK, there's two ways of doing it. One is using handoffs, and the other is using as tool to convert an agent into a tool. And there are pros and cons, and there are different use cases for using them. And the big distinction is that when it's a handoff, but control is passed over to that other agent, and it's now delegated to the other agent to continue work and take it from there. When it's a tool, it's more of a request response. We will use that tool and the response will come back to the agent that initiated it. And that's the mode we're working on right now. We want the researcher to be something which is just only there for the purposes of helping the trader. And that's why it makes sense to convert the researcher to a tool. And you give it a tool name, researcher, and you describe the tool. This tool researches online for news and opportunities. Describe what kind of research you are looking for. So that would become the input to this tool. And if you need a refresher on that, then just drop back to week 2 when we had so much fun with both handoffs and tools. Okay. So in the past, when we've used MCP servers, we've used something called a context manager, which is when you have stuff like you say with MCP Studio Server, something like that, as server. When you use a context manager like that, what happens is that behind the scenes, the server, this server here, is called with connect. Server.connect is called immediately when you do this. And then whenever it comes out of scope, then automatically server.cleanup is called, which cleans up resources and stops connecting to the server. We are not going to do it that way this time. We're going to separately connect and later clean up, because we're going to want to distribute this over multiple cells. So we don't want to be constrained by having it in one context manager, but it's the same thing. So this here, when we're going to say for all of the servers in our list of research servers, await server.connect. That's what happens automatically at the beginning of the with statement. And then we are going to call our researcher, passing in the research servers. And then we are going to call runner.run, saying, what's the latest news on Amazon? And then display the result. So this is us using this researcher. We're just going direct. We're not going through the tool, but it's the same idea. And we're asking for news on Amazon. Let's see how it does. It's thinking about that. It's no doubt showing some autonomy. Remember, it has access to either run a headless browser or it can call the Brave API. And it's got some news as of now. So it's got the current date well, the bid to acquire TikTok, the spring sale success, new Prime Video content. So there's some interesting stuff there that's coming from the news. So it shows that our research agent is working nicely. And again, it's the reason I like working in notebooks like this, as we are iterating, because we're in this experimenter's mindset where we try different things, explore different agents, make sure they're behaving the way we want before we move to a Python module. It's a great mode to work in as a scientist, first and foremost, before you become the engineer. But the other part of being a scientist is that we should come and look at the trace in the platform.openai.com, going to traces to see what's happened. And there is a trace for researcher. In we come, and we can see what's gone on here. It's found out what MCP tools it has. It's used the Brave search. It's used it twice. It's done 2 different searches. Latest news on Amazon and Amazon News April 2025. So a couple of different searches it's done. It's got back the results, and it used that to craft its response that we already saw. So this is the trace. This is showing what was going on, that it was at work, and yeah, that's all good to see. Okay, so back we go, and now we move on to our trader. So our trader, we're going to give our trader a strategy. So I'm going to name our traders by the standard cryptocurrency names that they give things beginning with A, B, and C. So Alice is our first trader. And yeah, so we begin by giving Alice a trading strategy. You are a day trader that aggressively buys and sells shares based on news and market conditions. And we're going to use account.getAlice, and we're going to call a method reset on account that resets Alice's strategy to this strategy here. And it also takes her money to exactly 10,000 to a starting position. So this gets us to our starting point. And obviously we're calling the account code directly. There's no point in using an MCP tool for this. This is just us getting things ready, getting our environment prepared. Okay. And then once we've done that, I will use MCP to show you. We will use it to call reading the resources. And there are actually 2 resources. There's one for looking at Alice's account, and there's one for looking at her investment strategy that we've hopefully just set. When we call these, it will be in the account code. So it'll be in here. When we call reset, it's going to both create Alice's account and set it up, but it's also going to then save it into the database. So if we look at the reset method right here, it sets the balance to the initial balance, sets the strategy to the strategy, wipes out the holdings and the time series, and then saves. And save is going to save everything down to our SQLite database. So let's run this and see if it all works. Well, it did, and it was very fast. So we've got a trader called Alice who's got 10,000 in the bank, no holdings, no transactions, and a total portfolio value of 10,000. And that is Alice's investment strategy. A day trader aggressively buys and sells. So far, so good. And now, time to create our trader agent. Okay, so this is it. This is the agent for Alice. So the account details is that we are going to read that from the resource. Same for the strategy. We put together some instructions, the system prompt. You're a trader that manages a portfolio of shares. Your name is Alice. Your account is under the name Alice. You have access to tools to search the internet, to check stock prices, to buy and sell shares. Your investment strategy is this, and your account holdings and balance is this. Your tools to do this. We should also say, we should add in here, you have tools to save memory of companies' research and thinking so far. So we'll give Alice some knowledge of the fact that Alice has the persistent tools as well. Use your tools to make decisions about the market, investigate, make your decision, make the trades, and respond with a summary of your actions. That's great. So let's just see that printed out now with the stuff in it. And what you'll see is that the current holdings and the balance have been written in there. And you'll see that the strategy is in here as well. There it is. So it's all clearly laid out. And now it's time for us to run our trader. So this here is going to connect with all of our servers. And actually, we can just write that simply. We can make that for server in MCP servers, await server.connect. So that will just connect all of our servers so that they should all be ready to go. And we will now call to get the researcher tool, passing in the researcher servers, and then we are going to create a trader called Alice. We're going to pass in that system prompt, those instructions. For the tools, we're going to pass in the trader tools, which is either an empty list or it's a list of the free tools for market if you're going with the free approach. And then we're going to add in our researcher tool right here. We're going to pass in our MCP servers, and we're going to then runner.run. That is, of course, the way that we kick off the entire run, including delegating to the tool to call the researcher and putting all of the result back in the variable result. Okay, let's see what happens. Off it goes. It's going to think about that. While it's doing that, I might just set, maybe we should, right after this, we would want to print the, oh, sorry, I've got that already. We're displaying it right here. Well, then maybe right afterwards, we'll want to go and have a look at our trace. I'll do that while it's thinking, which is a platform.openai.com/traces. Okay, well, here we go. It completed. Market overview. The market is experiencing significant downturns with major indices declining due to tariffs, which is happening right now. Here are some stock price movements. And so it's made some trading activities. It claims that it has purchased 10 shares of Netflix, tried to sell 10 shares of Apple. Well, that seems a bit silly. It says it didn't hold any shares, so no doubt it, no surprise that it complained. Maybe it was trying to go short. Maybe we should say that you're not allowed to sell shares you don't have. There we go. Then this is the summary at the end. So let's first of all see if we agree with that. Let's read the account's resource and see what's happened. So it does indeed at this time hold 10 Netflix shares. So the trading decision worked. It did buy 10 shares of Netflix just as it thought it did. And those are the transactions that it's made right there. And it's got the rationale in here that it's written against that, and the portfolio value and the trading loss, a tiny trading loss because of the trading fees, the bid offer spread. And so there we go. We've just seen a successful trading run, decisions made, and we've seen many MCP tools being used. It's used the tools to search the web. It's used the financial tools to look up share prices and financial news. And then it's used our tools to actually make the trade. So let's go and look at the trace now in OpenAI. So here it is, Alice, because we did that, the 13 different tools. Wow, let's take a look at what happened. So there's a lot of lists that went on. So first of all, the researcher was called, the researcher which was in there as a tool. It was collaborating as a tool. And the researcher also, of course, listed its tools, and it did a total of 3 Brave searches. It looked for the current market, top performing stocks. It did, as that's great. Current market trends, stocks, April 2025. So it did a bunch of web search queries to gather that information. And you can see that it's definitely taking the Brave search in favor of just trying to retrieve web pages itself. And you can see this, we have to press load more to get more. So we can see that then the trading agent went and got lots of stock prices, Amazon, Apple, Microsoft, Tesla, Google, and Netflix. It got all of those, and then it decided to buy some shares. It bought Netflix shares, and then just as it said, it tried to sell Apple and it got the error back, and it tried to sell Tesla and got the error back, and then it crafted its response back to us. So the trace is where we can go and see everything that happened, see all of the activities that our trader carried out, and see its sort of inner thoughts as it did it. And so this is super useful to see what's going on behind the scenes and to confirm that our trader and researcher are collaborating and working exactly as we planned. And so this is the moment now when we make the transition from being a scientist to an engineer. We've done our experimentation. We've explored some agent configurations. We've figured out that this combination of researcher and the trader makes sense and is working well for us. And now we're going to move to building our Python module. And so I want to take you there. It's called traders.py, and it is quite long. There's quite a lot here, but it is just everything we've just done in that lab turned into a module. There's nothing else to it. So you already know this stuff. It's just presented differently. And it's one of the reasons, again, it would be a lot to take on board to go through all this code from nothing. But if you've built up to it in a lab, then you're ready to construct this. So this is there's imports, there's load.env at the top, of course. Now this here is one thing I need to draw your attention to, because it's the one thing that you might need to come in and change. If you're using the paid market data MCP server, then you need to turn this to being your directory where that's running. And sorry to give you something to come in and do in the middle of this code, but that's just the one thing that is coded there. And I don't know where you will have git cloned that repo, so I can't speculate on that for you. So I'll let you do that. And then basically this makes a determination whether you're going free or not based on if you've got an API key for the paid product in your .env, then it assumes you want to use that. So only set that API key if you actually want it to use it. And again, so it's 1 cent for every lookup. So just be aware of that. So we're also going to get the DeepSeek API key and the Google API key, because in time we're going to be using a combination of OpenAI and DeepSeek and Gemini together to do this. But you don't need to do that. And for now, we're not going to touch this today. That will be for tomorrow. And I've got the base URLs coded here so that we can use it. And max turns is something I'm using. You may remember this from when we used LangGraph, that LangGraph would error out if it took more than 25 turns. So this is something to control how deep down the agent interactions will go before it will throw an error and say, okay, enough is enough. All right. So the way with OpenAI Agents SDK that you specify if you want to use a different client to swap out from OpenAI is this way. You create an async OpenAI instance like this. And so this is showing the Gemini client as an example. And we will use that potentially in this case for Gemini Flash right there. And somewhere there should be a DeepSeek client too. I don't see that there, so we should put that in right now. Let's copy this and make a DeepSeek client as well. DeepSeek client. And this should be, of course, the DeepSeek base URL. And that should be, Cursor has helped us out there. That is perfect. Okay, good. We now have our clients. All right. And then this next part right here is simply setting up the MCP servers just as we did in the lab. The trader MCP server parameters is going to use accounts and it's going to use memory. If we're using free market data, if we're using paid market data, then we're also going to add in the paid MCP server. And otherwise, if we're using the free one, then we will collect the tools later. And then for the researcher, we're going to use the MCP server for fetch and the MCP server for Brave. And that has set up our params. We've now organized the params for our MCP servers into different lists, and we're ready to get going with the code. All right, so now we've set up our params. We now have 3 utility functions before we get to the meat of the module. First of all, get model, very simple. You pass in a model name and it's going to return one of these OpenAI chat completions models, or string if it's just GPT-4o Mini. So if you pass in DeepSeek chat, it's going to create one of these guys using the DeepSeek client. If it's Gemini, it will create one of them using the Gemini client, otherwise just the model name, just to simplify some of our code later. And then this is get researcher. This is exactly the same as we had before. This gets our researcher agent. It's got the system prompt for the researcher, including the current date, just as we said. And then it creates the agent, and we pass in the MCP servers just as we did before. We populate them and we return the researcher. And then the final utility is to wrap this in a tool. Return the researcher as a tool because we're going to use it in the request response kind of mode. And so for this, this just calls the get researcher function and then returns that as tool being the way that you convert the agent into a tool. And we give it a name researcher and we give the description of the tool just as we did before. And that is the end of our utilities. We're into creating our class trader. Okay, here we go. So a trader has a name. It has an underlying agent. It has a model name we'll set it up with. And then it has something that it has an account that will populate when we read its account details. We store its MCP servers right here, and then a combination of the MCP servers of both. So this here, we're actually instantiating, we're creating an MCP server studio instance for each of the different parameters by iterating through them. So they are held at the instance of trader. Okay, and then we have here something which is going to set the system prompt for our trader agent. And it says, you are, its name, a trader on the stock market. Your account is under your name. And now this stuff is basically the same as what we had in the lab, with one tiny difference, which is that I'm saying that you actively manage your portfolio according to your strategy, but I'm not actually getting it to put its strategy in the system prompt. So it's not going to do that. It's going to put that in the user prompt. And why is that, you may ask? Well, that's because I have wild plans in the next time, in tomorrow, we might update this so that it can actually change its strategy as part of what it does, because I think that would be really cool if it has the ability to actually change its own strategy. We'll see if we want to do that. Yeah, so there's then get tools, which is simply going to populate the tools that this has. And if you're using free market data, then this is where it's going to use the MCP client that I wrote and then use that to build some tools that we can call directly from our LLM. The researcher is using that utility function to get a tool that wraps our researcher agent, and then we return those tools. This function connect to MCP servers iterates through all of our MCP servers and calls connect. All right, and then init agent does the connection I just said, and then it gets the instructions, gets the tools, and then it creates the underlying agent that it stores in the instance variable agent. And it is an agent with its name. It could be Alice, it could be whatever, with its instructions, with the underlying model. And this is where it calls that utility function to get model, given its name. The tools and the MCP servers are all set up. So now the underlying agent instance variable will now be populated with an agent. And it gets the account to the starting position and it returns the agent. Okay, so we're almost there. We're almost ready for action. Okay, it's time for a great function called a method called trade. This is the one. This is where the meat happens. And it's the same, again, as the one in the lab. We get the account, we get the strategy, and we say, based on your investment strategy, you should now look for new opportunities. Use the research tool to find news and opportunities consistent with your strategy. Use the tools to research stock prices and other company information. Finally, make your decision. You don't need to rebalance your portfolio. You'll be asked to do so later. It's a little thing that I'm going to add in here. We didn't do it in the lab. Just make your trades on your strategy as needed. I'm not going to say a reminder of, that's a mistake because we don't say it before. Your investment strategy, and then we lay out the investment strategy. Here is your account, and we give it its account. Here is the current date, we tell it. And now carry out your analysis, make your decision, and add a trade as necessary. After you've made your trades, respond with a brief 2 to 3 sentence appraisal of your portfolio and its outlook, and we'll store that in self.trading. So that's going to be convenient for us to look at later. Okay. Now it seems like we should also be mentioning the fact that it has, yes, we've got the we've got this mention about your entity tools as persistent memory. Let me make that point again here so that it knows that it can do that. Use the entity tools to store and recall information. I will take what cursor suggests. Perfect. That seems a nice thing to add. All right. And then we've got something very similar called rebalance, which is the same kind of thing, but it's saying, think about your current portfolio, your current holdings, and decide whether to change them. So this is an example of the same agent getting two different prompts, which is another sort of degree of freedom. You've got the idea of how many different agents, how do you carve up your problem into different autonomous agents? And then within a given agent, how many different prompts do I use? And this should be familiar to you because in Crew, this is what they organize things around both your agents and your tasks. So task was a kind of first-class object in Crew land. In OpenAI Agents SDK, it doesn't particularly have that. It just has different runner.run, different things you might do. And the way we're doing it is we've just got two different functions, trade and rebalance, two different steps, and we're calling it like this. So it's a good example of how Crew is a bit more opinionated. Crew gives us this construct of a task separate to an agent, whereas OpenAI a little bit more flexible. There's just the agent, and then it's up to you if you want to call it multiple times or how you want to organize yourself around it. So these are like two different tasks for the same agent. And it's an interesting agentic design question that you have to wrestle through about to what extent do you divide up your bigger problem into different agents, and then to what extent do you do that into different tasks. And if you're going to ask me, how do you go about making that decision? You know what the answer is. You experiment. You try out some different approaches and you see which one performs best. Okay, so we've got the rebalance is very similar to the trade, and it makes just the instruction that it should look to rebalance based on your strategy with your investment strategy listed out. And we'll take out the words reminder, just make it consistent. There we go. So those are our two big tasks that we're assigning for this agent. Okay, and now we have the run method. Just before we look at that, I should just quickly talk through a bit more this runner.run here, because I think I went through this too quickly. Both trade and rebalance both have this with runner.run, and I just noticed there, look, we're missing the trace here, so we should absolutely have that in there with trace self.name. Let's make this a little bit better. So we will trace and we'll say self.name trading. And then down below, we'll have this as rebalancing so that it's very clear what's going on. Here we go with trace. Cursor is interfering a bit. Not sure what's happening there. There we go. Self.trade, rebalancing. So this way we will see it traced separately. And it's important to take time over your traces, because this is really the only insight you get into what's going on. And you need to make sure that you can clearly distinguish different activities. So now our different tasks, basically, to use Crew's language, are being traced with different names. And then we're calling runner.run. We're passing in the agent, our underlying agent, the message that we just wrote, and we've got this max turns. This is where we specify don't go over 30 different LLM calls to get to the outcome. And last time it was in the teens, so we should be safe. We have some headroom in there if it goes on for a long time, but hopefully it will stop it from going off the rails. Okay, and so with that, the async run coroutine for this class, which says if we're in a do trade mode, then let's call iTrade method. Otherwise, call rebalance, and then reverse flip do trade. So do trade is a Boolean that will be toggled true, false, and depending on which one it is, we will either trade or we will rebalance, and then we will switch and return the result. So that really is it. There is at the bottom here a cleanup, which is the thing that goes through and cleans up. And that is what would have been called automatically if we were using with. So there is our module. I hope you like it. Now let's give it a whirl. Let's run it. Well, I hope you're excited for this. We're going back to lab 4. We are coming here. So we've looked through traders.py. I remind you again that there is that constant at the top that you need to change if you're using the paid market provider. Or you maybe decide to use a different market provider if you've looked for some good MCP tools. It might be worth doing that. And so now we import trader from traders. This is it. This is running that. It's happening. Now we're going to create an instance of trader and we're going to call it Alice. That seems to work. Okay. Now we are going to call init agent, which of course we have to await because it's async. So this is going to do things like creating all of our MCP servers. So this takes a little bit of time. All our MCP servers are creating and getting called. Done. So now we have an agent, name is Alice. There are Alice's instructions, and you can look through all that. There's all of the tools are in there, and it's time for us to kick this off. So off it goes. So Alice is now running, and there could be a lot of calls involved as before, but this time we are going through the module. Now, because we have that flag that goes true, false, it's going to start by doing trading rather than rebalancing. But we will let Alice do her thing. I'm just going to check now that we should add in here some markdown to look at this, of course, to look. Oh, and Alice is finished already. But we should go and look at the trace. But first, let's look at the results so we can see. I'm too eager. So let's see. Trades executed. Bought 5 shares of Tesla. Bought 10 shares of NVIDIA. Rationale, high trading volume indicates potential for short-term gains. Remaining balance is 299. And portfolio appraisal. My portfolio now includes shares which are poised for potential rebounds amidst a volatile market. This all sounds perfectly sensible. I'm excited to see the trace. So as before, we go to platform.openai.com/traces. And even though this output looks very legit, we shouldn't get excited until we've done the work to go and look at the trace and understand what's happening and confirm that this is performing as we would like. So there was 11 different tools in Alice-trading, which was what we were hoping to see. And what we can see here, okay, so Alice started with listing a bunch of tools. It went to the researcher who just did one web search this time, latest stock market news, and that came back. A lot of currents. Wow, lots of checking of market prices for Tesla, for NVIDIA, for Amazon, for EEM, and it says unable to fetch current price or no price found. And PG, is that Procter & Gamble? And okay. And then buy shares for Tesla, buy shares for NVIDIA, buy shares for Amazon. And that was the response. So it definitely did its work. It got the current stock market price. It bought the shares. That is all great to see. Okay, and I've now gone through and run a bunch more times for trading and rebalancing. It switches each time so we can see a bit of activity going on. Occasionally, I've had MCP tools erroring, as it has done here, and so that might be a cause for concern. And we can go and have a look at why, of course, by looking at the trace. But let's first see the final portfolio after rebalancing. Netflix is at 10 shares, Tesla at 10 shares, 5 were bought, and that leads a cash balance, and net profit and loss is down $60 on the trading activity of now. So not the best of times, but I think the markets are turbulent. And so there's some explanation here of why it did what it did. But now let's go look at the trace. So here is the trace, and we'll see why tools were erroring. You'll see I've been doing trading, rebalancing. So Alice did some get company news, and that had an error with the get company news route. That is currently that tool, which is one of the tools, the free tools offered by the paid financial services MCP tool that we're using is not working. And so Alice instead just picked current stock price, which is working and which gave back a good stock price. So Alice wasn't perturbed by some ill behavior from one API and just switched to other areas, and then used the researcher tool, which would be a better way to get company news. And the researcher tool went off and did some research, and the research tool got some information about Netflix. But on asking for some information on Apple, it got an error that the rate limit was exceeded because I've been running this too much, which is another little problem to be aware of. And unperturbed, Alice kept trying, or the researcher kept trying. And in the end, got another response after a while, after doing a big query on some things. But this may indicate that I need to put in some sort of a pause to make sure that these things don't mean that we get rate limits from the Brave web search. But anyway, after doing all of that, after managing the fact that there were errors, I love the fact that the autonomous agent was able to handle, it was retrying itself. I didn't give any instruction to retry. And also when the Get Company News failed, it flipped over to the researcher instead. So it's really interesting to see that the agent is able to handle unexpected outcomes. And as a result, there has been some trading, there has been some rebalancing, and this is the final outcome at this point. And so that completes the first part of our two-parter on our capstone project on building an autonomous agentic platform for making trading decisions. And it was a lot of fun. The thing to really bear in mind, the main learning point, is that these kinds of agent platforms can be very powerful. They could, because by the nature of their autonomy, they are able to do things like handle API calls that aren't working and just trying out different approaches for getting their information, which is extremely powerful and something that we wouldn't have thought possible only a few years ago. And this is why people are so excited about these kinds of platforms. And then we're also seeing the power of MCP, the fact that there are all these different tools for the agents to be using, and that they are experimenting with using different tools. You even saw in the last one how it tried using the get market information from one MCP server, and when that failed, it flipped to using its research tool, which ends up using Brave searches. So it's amazing to see how bringing together these different tools from MCP servers from different authors across the world has allowed us to give extra capabilities, integrate capabilities into our agents really easily. And so that completes day 4 of our final week. I do hope you're enjoying it. I hope you're taking as much pleasure in this financial services, this autonomous alpha-seeking agents as I am, and prepare yourself for the grand finale in the last day. I will see you then.